In this video, we shall take a look at a few examples of solving simultaneous equations with one of them being nonlinear. Example: 3x plus 4y plus 7 equals 0 and x squared plus 3y equals 31. That's equation 1 and this equation 2. As per the procedure, identify the linear equation, which is equation number 1. Equation 2 has powers, so therefore nonlinear. To be more specific, it's a quadratic equation. The linear equation is in terms of x and y, so we have an option to either make x or y the subject of formula. And in this example, let's do both. This would be for x and this would be for y, and label them equation 3 and 4. A decision has to be made. Which one of the two are we going to select and substitute into the nonlinear equation, which is equation 2? You have two options, but note that your selection of which term to substitute can result in a simple or a tedious working. Equation 2 has a square on the x, which means when you substitute the x in it by using equation 3, you will have to deal with squaring a polynomial with fractions in them, therefore requiring more number of steps to arrive at the solutions. Alternatively, you could substitute the y in equation 2 using equation 4, resulting in no need of a squaring, but you still have to deal with fractions. You can see that substituting y requires a much shorter working and less prone to careless mistakes. So in your exams, you should see ahead and make a wise decision as to which term to substitute to save time and avoid careless mistakes. Nevertheless, both options will lead to the same answers. You get the same value pairs. As to why you get two solutions, a graphical approach will give you the answer. Equation 1 is linear, and when expressed in the form y equals mx plus c, gives a straight line with a negative gradient. Equation 2 is nonlinear and is a quadratic, an N-shaped graph due to the negative coefficient of the x squared term. And with that, you have three possible scenarios. The straight line could be missing the graph, not touching nor cutting it, therefore no solution would have been obtained. Or the straight line could be just touching it, which means you would have gotten only one solution, that is one value pair. In our example, the straight line is definitely cutting the graph, because it's only in this situation where you can get two solutions, that is 2 points of intersection, thus two value pairs.